Okay, the math professor is on the air once more. All right, so today's lecture is going to be on how we use PERT and how do we calculate our probability of finishing on time. All right, so I am going to do exercise 7-1 from your textbook, and that is on page 244. All right. Now, arrange things a bit better. All right, so we have on page 244, we have a table of how we're going to do a project. This is a national holiday toy project, and the question is, what is the probability that we'll finish that within 93 time units? Okay, 93 time units. All right, so we have the identification of the of each activity. We have a description. We have the predecessor activity. We have the optimistic time, the most likely time, and the pessimistic time. So we want to calculate the PERT time, and we want to calculate the variance. Of course, it helps a lot if you can remember how to spell variance. All right. So, our ID is given as 1 through 7. So for 1, the description is design the package. The predecessor is none. That's the first activity. The optimistic time for this is 6. The most likely time is 12, and the pessimistic time is 24. All right, so activity 2 is design the product. Predecessor activity is 1. The optimistic time for that is 16. The most likely time is 19. And the pessimistic time is 28. Then activity 3 is build the package. The predecessor is 1 for that. The optimistic time is 4, most likely is 7, and pessimistic is 10. Activity 4 is secure the patent. The predecessor activity for that is 2. The optimistic time is 24. The most likely time is 27. And the pessimistic time is 36. Can I help you?
Yeah, sorry to interrupt. This is for the packages that I delivered. You have to sign.
Okay, I feel important. I'm getting packages during my class presentation. And you delivered those in 322?
Yes.
Thank you very much, sir.
Sir, have a good day.
Okay, meanwhile, back at the ranch, our ID for activity 5 is, our description is build the product. That also has a predecessor of 2. Optimistic time is 17, most likely is 29, and pessimistic is 47. Activity 6 is paint. The predecessors are 3, 4, and 5. The optimistic time is 4. The most likely time is 7, and the pessimistic time is 10. And then test the market is our 7th activity, and the predecessor for that is 6, and our optimistic time is 13 time periods, most likely is 16, and 19 is our pessimistic time. All right, well, it's super easy, of course, to calculate now using our Pert formula. Our Pert formula, as you will remember, is equals left parenthesis our optimistic time plus 4 times our most likely time plus our pessimistic time, right parenthesis, divided by 6. That gives us our Pert time, which is a weighted average. All right, and I just pull that formula down, and I have all of our times. Now, how do we calculate variance? Well, we talked a little bit about that before, but I'm going to go ahead and insert an equation, which of course never ends up where you expect it to. All right, so our variance is equal to our 2 left parentheses, our pessimistic minus optimistic divided by 6 and then that is raised to the 2nd power. So let me, come on, there you go. All right, so that's how we get our variance. Therefore, our variance of our number one, design the package, equals, two parentheses, pessimistic minus optimistic, right parenthesis, divide by 6, right parenthesis. Now I can go ahead and cheat by just putting caret, that is the sign that is right over the 6th on your keyboard, 2. And that gives me my variance. And I can get the rest of them just by pulling this down. All right, so now I have my variances. And you'll notice, oh, what luck that that I was able to do that in a way where I have these square cells here. All right, so, well, first of all, I'm going to have now, I have to admit, I cheated a little bit and I already worked through this exercise. So I already know how I want to set this up. Do I know how I want to set it up? Yes, I do. All right, I'm going to go ahead and pull this down a little bit. Make sure I've got copy. All right. And I'm going to do one here. And here. All right. So we know that we always start at 0. All right. This is the first activity, so I equal my A4, my ID, equal B4, my description, and equal, now what I'm going to do, the first pass through this is do it on the most likely time. All right, then I'm going to be able to say equals my early start time plus my duration. All right, we know that that means 2 and 3 split out from number 1. Okay, so I'm going to go ahead and insert arrows that indicate that. So I've got one from 1 to 2. I'll go ahead and make that black. I want to put another one in here and make that black. All right, so my start time is going to be equal, my early start time is going to be equal to my early finish time for activity 1. My ID is going to be equal to 2. My description is going to be design product, and my duration is going to be equal to the most likely time, which is 19. All right, so I come down here, equals, again, my early start time is going to be equal to my early finish time. Tab over, equal, my ID is 3. My description is build package. And my duration, I'm going to put as the most likely time. All right, so I come up here, I know that my early finish time is going to be equal to my early start time plus my duration, right? And that is going to be the same for both activities 2 and 3. The way we calculate it, not the number. All right. Our ID time, our ID here is going to be equal to 4 the description is going to be secure patent, and the time is going to be the most likely time. All right, and here we have activity number 5. That is equal to build the product, and the duration is equal to the most likely time to build the product. All right, both of these activities split off from design the product. All right, so I'll go ahead and I'll put in the arrows that would indicate that. All right, what is my early start time on securing the patent? It's going to be equal to my early finish time on design the product. And that is going to be the same for build the product. All right, so the early finish time for those is going to be equal to the early start time plus the duration, and again, equals the early start time plus duration. All right, now 3, 4, and 5 go into 6 here. So I'm going to go ahead and put in my arrows that indicate that. What happened? Oh, okay. Shape. All right, so 3 goes into 6. Excuse me, 4 goes into 6. 5 goes into 6. And 3 goes into 6. All right. Now we know that this is activity number 6. The description equals paint. And the duration is the most likely time. All right, now, remember, how do we choose amongst these early finish times? We say it's going to be the maximum of our early finish for 4, our early finish for 5, and our early finish for 3. Once again, our early finish time is our early start time plus duration. All right, well, we have to insert one more arrow from paint Okay, so this is our activity number 7 equals number 7 equals our description, which is test market, and equals our duration, which we are taking as our most likely time. All right, well, once again, our early start time is the early finish time of our previous, and our early finish time is our early start time plus our duration. All right, so that gives us 83, which I am for the moment going to take as my mean mean just means that it is the average time we would expect this to be done in. So equals 83. All right, well, we've calculated our variance, but how do we calculate our z number, right? Our z number is the number of standard deviations away from our mean, either in a positive or a negative direction. Variance can never be negative. Variance tells us what the width of the distribution is. All right, so the probability that Z, capital Z, equals Z equals our X minus basic math. I don't want that. I want Greek letters. And I want the letter mu. Divided by the standard deviation. And there is sigma, which stands for the standard deviation. Okay. So we get our probability that Z equals Z equals, and we're just going to say, so they ask, what is the probability that will finish in 93 time units? All right, so that means that X equals 93. All right, so 93, I hard-coded in. Our mean for most likely is equal to 83, so I click on that, and I close parenthesis and divide by. Now, how do I get my standard deviation? Well, standard deviation is going to be the square root of all my variances added together. So I'm going to put the square root function, SQRT, but it's got to be the addition, so I put sum, I highlight all those numbers, right parenthesis, and that gives me my Z number. All right. Now, you're saying to yourself, okay, well, I can look that up in my in the table in my book that's also on 244. But you know what? It's a bit of a blunt instrument. What I am going to do is say probability that X equals 93 equals, and I'm just going to cheat and go equals norm, and I put norm S dist. Okay, and what that's going to do is it's going to convert my Z number to the probability. All right, so I click on my Z number, comma, and then do I want it to be cumulative or do I want it to be the probability density function at that place? Well, I actually want cumulative. So I put true. All right, then a quick clicking on the cell, going up here and clicking on the percent style. All right, so it's 93% if we take our mean as being the 83 of the most likely. But what if we don't take that as the most likely? let me copy this. What if instead we calculate that using our PERT? All right, so in that case, I'm going to refill out. All right, so it's A4. I know this is going to be equal to B4, and then this is going to be equal to G4. Right? You'll notice my mathematical reasoning stays intact here. All right, this is going to be equal to A5 equals B5 equals G5 equals A6 equals B6 equals G6 equals A7 equals B7 and equals G7. Uh-oh. Which is this? All right, A6. Excuse me, equals A6 equals B6 equals G6. And then here it's equals A7 equals B7 equals G7. All right, oh, thank God for that. All right, equals A8 equals A9. Oh, excuse me, doesn't equal A9. Equals B8 equals G8. All right, there we go. And equals A9 equals B9 equals G9. And finally we get to equals A10 equals B10 equals G10. All right, so here our PERT mean becomes equal to 86. All right, so what effect is that going to have here? All right, well, our probability Z equals Z is going to be equal, left parenthesis, oh, that's not an equal sign, equal left parenthesis to 93 minus 86, right parenthesis, and again we're going to go square root of the sum of our variances, right parenthesis, all the way home. So our probability that X equals 93 under these circumstances becomes equals norm S distribution, my Z number true and so when I convert that to a percentage, it's 85%. Okay, so either way, we have a good probability of being able to finish the product and all the steps in our network before the deadline of 93 time units. Okay, well, thank you very much for watching this presentation. I really appreciate it. And when the fields are white with daisies, we'll meet again.